This is Software Engineering Radio, the podcast for professional developers on the web at SE-Radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. This episode of SE Radio is brought to you by Braintree. If you think that your payment system exists solely for the purpose of transferring money from your customer's wallet to yours, think again. Braintree. Rethink payments. Learn more at braintreepayments.com/SE-Radio.
Welcome everyone to the Software Engineering Radio. My name's Kim Carter. I'm going to be hosting the show today. And today we've got Neal Ford.
Hello. How are you?
Yeah, good. So Neal is Director, Software Architect and Mimi Wrangler at the software company ThoughtWorks. He has spoken at hundreds of developer conferences. Neal has a degree in computer science from Georgia State University, specialising in languages and compilers, and a minor in mathematics, specialising in statistical analysis. He is an internationally recognised expert on software development and delivery, especially in the intersection of agile engineering techniques and software architecture. Neal has authored magazines, articles, 7 books and counting, and dozens of video presentations. His topics include software architecture, continuous delivery, functional programming, and you can find out more about Neal at his website, nealford.com. So welcome to the show, Neal.
Thanks. I'm happy to be here.
So I've got a bit of a lead in here from a previous show. It was Rebecca Parsons with show number 236. Did a show on evolutionary architecture.
Yes, she and I are writing a book about that subject right now as we speak. It's my 8th book.
Yeah, awesome. So we're going to be covering a different topic today around the skills and architectural needs to be successful in order to be an architect.
Which is closely related to my 2 books ago called Presentation Patterns, which is one of the soft skills you need as an architect.
Can you briefly describe, Neal, what your new book is about and where people will be able to find it?
The new book on evolutionary architecture. There's a website called evolutionaryarchitecture.com, which has updates on the conference presentations and the articles that we've written about the subject so far. We're in sort of first draft stage of the book right now, so we are very close to being finished with it. So hope to get it published sometime, certainly later this year and maybe as early as the second quarter.
So in your own words, what is a software architect?
That's interesting because one of the other things that I do as part of my professional world is I'm sort of the mascot for all things software architecture at O'Reilly, the publisher. So I'm sort of their subject matter expert on things software architecture, including conference co-chair for the O'Reilly Software Architecture Conference, which is coming up in New York in April. And one of the things that the people at O'Reilly have been trying to get me to do is define software architecture, and I keep refusing to do so. Because I don't think it's possible to define it because it's way too multifaceted. I had a friend at one point put together a mind map of all the responsibilities of an enterprise architect, and it's massive, all the things that architects end up touching. And so rather than try to create, a single definition, what we've tried to do is create sort of, almost like hashtags of characteristics that architects face every day. And certainly it's all the technical stuff that you would expect as an architect, but I think the thing that blindsides most burgeoning architects, or we actually have a special category called accidental architects, where people on a project that are making architectural decisions, they just don't have the title. Because, if you look at architecture as from a technical standpoint as the decisions that have long-term implications, then even on a 2-person project, you're making those kind of decisions. You just don't have the formal business card that says architect on it. But the thing that really trips up brand new burgeoning architects and accidental architects who finally realize that the official role are all the soft skills. One of the things that blindsides people is, suddenly now you're having to have written correspondence with people who didn't skip all the English classes to go hang out in the computer lab and play with, computer simulations and that kind of stuff. So suddenly all of your written interaction is held to a much higher standard than it was before, and that trips a lot of people up.
So for a while I've had this metaphor of the architect's role as being this person that rides the elevator of a tall building all day. Architects seem to be jack of all trades and master of none, or few. Riding the elevator to the basement where the engineers work and up to the top floor where the C-levels work, and translating one to the other. Is that how you see the architect's role?
Well, absolutely. And that gets to that multifaceted aspect of architect, because as soon as you start trying to pin it down, you'll realize that, oh, well, the architect has to do that as well. And, oh, they have to do that. And in fact, I think that has gotten even more complex over the last few years as we've really delved into these kind of agile engineering practices like continuous delivery, because suddenly now architects have to start thinking about the DevOps implications of the architectures they're designing much earlier, which at the end of the day is a good thing because it gets a faster feedback loop going between the architecture and operations and what it takes to actually operationalize an architecture. But it also means that an architect's responsibility is broader now because you have to start thinking about things like DevOps and things that used to be comfortably tucked away in their own silo. And of course, we realize that anytime you do that with software, you end up creating inadvertent friction. And so the best way to do software is with really good tight feedback loops.
So what do you think about the idea that architects are born predisposed with a special set of attributes?
I don't think that's necessarily true, although patience of a saint probably helps. And the ability to sit in meetings. So if you were born with a genetic defect that prevented you from sitting in meetings, you'd be miserable as an architect. Because that's the thing that a lot of architects find is they end up in a lot of meetings that they never had to go to before with, business type people with, very less interesting things than the kind of technical meetings they have. Certainly there's a leadership aspect to a software architect. And one of the things that I think people miss is that really effective software architects are good speakers and presenters. They're really good at conveying their ideas to not just technical people, but also business people. But I also don't think that's an innate talent. That's absolutely something you can practice. And so one of the things that we strongly encourage tech leads and burgeoning architects within ThoughtWorks to do is do presentations, do brown bag lunches, do presentations at conferences. The more practice you get at being able to express yourself in high pressure situations, the better you're going to find yourself positioned to do that when you become an architect.
What do you think the top 4 skills required are to be the best architect anyone can possibly be?
Last year, in preparation for the O'Reilly Software Architecture Conference, I actually wrote an article where we interviewed a bunch of architects, and one of the questions we asked them were, what do you think the most important characteristics an architect should have? And we got a lot of really interesting answers. You get the normal kind of things like, understanding having technical acumen and understanding technical issues, but a lot of those came down to soft skills, being able to reach compromise between disparate groups of people who all have their own priorities, being able to really express an architectural vision effectively to business people and technology people. That's extremely important. But another thing I think that's really important, so this would be number 3, I guess, is understanding the nature of knowledge itself in architecture. Here's what I mean by that. So as you are progressing through your technical career, what you're trying to do is learn more and more stuff deeply. So what you're working on is your technical depth. You're trying to become deeper technically and learning more and more very, very specific things. But when you reach the role of architect, it turns out that depth is not as valuable as breadth. Because as an architect, knowing that there are 5 different frameworks available that will allow you to implement this multi-threaded scheduling algorithm is better than knowing how to implement that algorithm in a specific framework like Akka. And so in some ways, architects have to shift the way they think about things and start gradually giving up some of the hard-won expertise that they garnered and give it up in exchange for getting more breadth. And that's always a painful thing for technologists to do, is give up on knowledge. But it actually behooves an architect to broaden their technology rather than narrow down to hyper-specific sorts of things. So that's the third thing, is understand that when you become an architect, the way that you gather information and the way that you think about things starts subtly shifting. And so you said 4 things. Here's the 4th one. So one of the things that we think about as architects a lot are all these ilities, all these architectural characteristics that we're trying to assess. In addition to things like business requirements, we also have these external factors like resiliency or scalability or security or things like that. All these ilities that we have to think about. But one of the ilities that I don't think architects wield nearly enough is feasibility. And this gets back to something I was talking about earlier about this expanding role of architect, because one of the side effects of the architect having a much broader role inside organizations now is that they have a much broader context on things like, should we even be trying to do this? And I think a lot of architects don't pull the feasibility card quickly enough to say, you know what, maybe this is not such a good idea. I know we say that it's a really tight time frame and really ambitious scope, and we'll try really hard, but maybe that's not going to work, and maybe we should think about something else. I think understanding feasibility as one of the most powerful ilities is also a really good skill for an architect to have.
Yeah, excellent points. So how do you deal with losing your technical skills due to constantly being pushed up the ladder? Like, I personally have to deal with quite a bit of frustration around this and feel constantly torn between needing to go deep on technical areas and then losing focus of the bigger picture, and vice versa. Is this an issue you face, and how do you deal with it?
Oh yeah, everyone who becomes more senior starts lamenting the fact that they don't get as much technical stuff under their belt anymore. And so there are 2 ways that we've kind of grown to attack this problem within ThoughtWorks. One of them is to, as the architect, carve out some stuff within the code base to work on. It should be non-critical path stuff. And one of the things that's really useful, because one of the things that you constantly have to do as an architect is assess new kinds of frameworks and tools to see how well they work within your ecosystem. Because you can read web pages about things like web frameworks and message queues, but until you've tried them in your real ecosystem, you don't understand what impact they'll have. And so doing those kind of agile spike exercises within your code base to assess new things to see how well they'll fit within your ecosystem allows you to stay in the code base and keep off of anybody's critical path, which is usually a good combination for architects because they get distracted so much. But the much better way, I think, to do this is to pair with people on your team on a really regular basis. Even if you're not a company that regularly does pair programming, this has a lot of different benefits. One, it allows the architect to get in the code base and see what's going on at the ground level some. This is also a great way to get junior developers up their skill level. This is just like playing with a tennis player that's better than you. It'll make you a better tennis player. Same is true if you're pair programming with someone who is much more experienced than you are, because you see problems come up in the context of a real code base and see the thought process of how they think about solving them and what steps they go through to solve them. So that's a really great way to serve two purposes. One, to get your hands in the code base, and also to upskill level for some of the people on the team. Or maybe it's not even upskilling level, but you're working on a part of the code base that's really, really difficult that would benefit from having 2 brains working on it. Maybe carve some of that time out to do some pair programming as well.
So what other ways do you use to attempt to retain the skills that you want to hang on to, like the skills and talents that you feel that are being taken away from you?
Well, I think some of them you just have to let go because you can't hold everything in your head. But there are some things that you hold on to just because they remain particular passion as for one reason or another. So one of the things that I'm holding on to and clutching on to for dear life is functional programming, and particularly Clojure. I really like functional programming and I love Clojure a lot. And so any sort of coding project that I do for myself tends to be in Clojure now, and that's the only real. I used to be a real language geek, and in fact, one of my books a million years ago was comparing a bunch of different Java web frameworks. So I love different languages, but I don't get a lot of time to dabble in that now because I'm spending so much time in the architecture space. But I do spend a little bit of time in Clojure just because it's such a beautiful, elegant language. So I think architects find some things that they continue to latch on to and still until, I mean, it almost becomes a hobby within your career of the stuff that you just can't bear to let go. So part of the job of architect is identifying, okay, which things can I not bear to let go, and which things can I, let sail off to sea.
So what techniques do you use to transfer essential information amongst software engineers in yourself and everyone else, other than adding more meetings, which are often counterproductive? I'm thinking of things like peer programming as being quite helpful there. I mean, what other techniques do you have though?
Yeah, peer programming is the best for sure. And this is something that I think we've always struggled with in architecture, is coming up with any kind of good specification language. Other kinds of engineering have come up with ways of creating schematics and other sorts of understandable things, but we struggle to do that in software. I don't think things like UML are particularly useful for this, because I think, and I've always had this theory, that UML is flawed because it's too technical for non-technical people, but it's not technical enough for technical people. It's not really deep enough to get really expressive from a technical standpoint, but it is technical enough so that you can show it to business people and they don't understand it. And so I've been looking at, as an alternative to something like UML, Simon Brown's C4 model. Simon Brown is a really well-known architect in the UK, and he's come up with this C4 model of doing capturing software diagrams. C4 stands for context, container, component, and class. The context being the larger business context, sort of what you'd normally capture in something like a use case about who the roles are interacting and the big moving parts. The containers are the physical partitioning of the system into things like physical infrastructure. Components are software components, either services or things like components, and then classes, of course, are just classes. I find that that's a more useful way to capture a lot of that kind of information because it's sort of targeted toward different audiences implicitly. So for example, the context diagram is sort of targeted for less technical, more business people who just want the kind of bigger picture, whereas as you drill down deeper, you get into more and more details of how those things look and work.
Yeah, Simon Brown's got a bunch of books on LeanPub too, which are quite good.
They are. And he's also open sourced a tool called Structurizer for both .NET and Java that allows you to, so you're asking, so this comes full circle, you're asking how do you stay in the code base? Well, Structurizer is one way to do that, where you actually write Java or C# code that generates all your software architecture diagrams. So it's an open source tool that you literally instantiate, the classes, and it draws the thing for you. So it seems like a lot of work to me, but if you're absolutely desperate to do some coding, then that seems like a good way to. And of course, generated diagrams are always typically better than hand-drawn ones. I worry about the overhead. But ultimately, the answer to your question, I think, and we've found this to be quite successful within ThoughtWorks, is this idea of a lightweight architecture decision record. This idea has been around for a long time, but it sort of regained popularity recently when Mike Nygaard of Cognitect released a blog entry about how they're using architecture decision records within Cognitect. And the idea is very lightweight, text-based document that is expected to go in version control right alongside the source code, typically in Markdown or ASCII doc or some sort of text-based markup language. And really what you're trying to capture there is just the essence of why we made this particular architectural decision. Because the problem is, you're presented with some sort of architectural decision, like, okay, we need to add, we have a current integration architecture, and we need to add external business-to-business integration, and we need to add website integration, and we have a message queue. Should we create a hub that sits in between those guys in the message queue or not? So that's a typical kind of architectural decision that you'll be presented with. And there are a lot of things that you have to think about as an architect to analyze to see if that's going to make sense or not. You have to think about single point of failure and scalability and what is the purpose. And so you're going to go through this analysis. It seems a shame to lose all that analysis once the decision's made and you decide, okay, we're going with a federated hub. And that's what you implement in code, but then all the analysis that went into that kind of disappears. That's really the goal of an architecture decision record, is to capture that analysis in as light a way as possible so it doesn't get lost. So part of an ADR record is the context in which you're making the decision, what the decision is, and what the backing supporting supporting evidence is, and then perhaps what you think of the side effect of this decision is going to be in the near-term future. And you can also mark a status on ADRs of either proposed, which means we're thinking about this, accepted, which means we're doing it, or superseded, which is also important because sometimes you make decisions for a perfectly legitimate reason within an architecture, and then the whole ecosystem changes underneath you, and suddenly that's not the appropriate decision anymore. It would be nice to still have the history of why we made that decision initially and then why we replaced it later, and so we're trying to capture that in ADRs as well. I don't think it's perfect. It's way far from perfect, and it's nowhere nearly as good engineering artifact as other engineering disciplines have, but we're still working on that. We're a very young engineering discipline compared to those others, so give us time, we'll come up with better stuff, but that's the best thing that I think we found so far.
So keeping things simple is often often harder than it sounds. Why do you think that is?
It's interesting you say that because this observation of mine that keeps coming up over and over again is, and I'm actually putting together a talk for this next year about stories every architect should know. I think one of the things that is bad about software architecture is that because there is so much stuff to know, we tend to always look in the future at new cool stuff and don't look in the past for really important lessons learned. And I'll just give you one of these. Pets.com. So the origin of this talk was when I was doing these software architecture fundamental training courses, I would ask people, do you know about Pets.com? And nobody knows about these really important stories from the past. So Pets.com is famous because they're the first company that was so successful it destroyed them. So they were, I don't know if you remember Pets.com, this may not have been an even phenomenon outside the US, but they were the first, they came out, they were going to be the Amazon of pet supplies. And so they came out with this massive marketing campaign with big commercials during sporting events and all that sort of stuff. The problem is they spent more money on marketing than they did on actual software infrastructure. And so when people were trying to place orders, it was crashing all the time. They were dropping orders, and their reputation became so bad that it destroyed the company. So they were the first company that was so successful that it destroyed them. So that's an example of one of these stories. But so one part of what I'm doing is I'm putting all these stories together is looking for the common theme or thread that kind of runs through them. And I think I found what that is. And it is the answer to your question of why do things get so complicated all the time? And it's an observation that I made a while ago, but I think it's still true. And that is that meta work is more interesting than work. I don't know of a single developer who wouldn't rather write a framework than use a framework to create something valuable for the business. Because writing a framework is cool, all these complex problems to solve and all these things that nobody's ever done before. So this is what I tell people is like, okay, when you really boil it down to its essence as a developer, and let's say you're describing this to your job to your grandparents, at the end of the day, you take things off web pages and put them in databases, and take things out of databases and put them on web pages. Yeah, there's a bunch of details in between all that stuff, but at the end of the day, that's kind of what you're doing. And as a developer, if you've done that for, 5 or 10 or 15 different projects, it gets kind of dull. So what developers do when they get dull is invent cool puzzles to solve. And that way, they've got a cool puzzle to solve every day when they come into work. That's meta work is more interesting than work. And I'll give you the perfect example of this that just came up on one of our clients. I was chatting with one of our clients, and they were talking to the infrastructure team of developers, and they were currently in the process of ripping out all the Angular front-end stuff and replacing it with React. And I said, so why are you guys doing that? Because, you're getting everything you need out of the Angular stuff. And it's like, well, we suspect that this is going to be better in the future, so we got a 2-year plan to replace all the Angular stuff with React. So, the Golden Gate Bridge in San Francisco, this famous iconic bridge, it's right there on the ocean. And one of the side effects of that is there's a crew that paints the Golden Gate Bridge. And they start on one end, and it takes them a year to get to the other end. And by the time they get to the other end, the original end already has enough salt damage, so they just start over. So that's their job, is to perpetually paint the Golden Gate Bridge. That's what this team of engineers is doing. They're painting the Golden Gate Bridge. They're not adding any business value. They've decided, you know what, talking to business people is messy and they're just going to give us a bunch of stuff we have to figure out and problems to solve. You know what, if we just play here in the infrastructure for the next 2 years, by the time we get all the React stuff in there, the next big web framework will be along and we can spend 2 years replacing that and never actually have to worry about talking with the messy business people or anything like that and just keep painting the Golden Gate Bridge. So I think that's why things get too complicated, is that meta work is more interesting than work. It's so hard to get back to simplicity because we love complicated little puzzles to solve. And so we keep over-engineering everything toward the goal of, well, I'm sure we're going to need this, or we keep justifying all these reasons for overcomplicating things when it's rare to find them. The legitimate reasons, I mean.
So why is history so important, and what should we learn from it?
Well, I mean, just like any sort of scientific endeavor, people are going to stumble and fall, and, it's nice not have to stumble and fall in the same way. It's important to understand a lot of these lessons about how to make decisions about things. So there's a great book about this. In fact, one of the stories is derived from this book called Dreaming in Code by Scott Rosenberg. And it's,
another one.
This book, it's an interesting book because it's the story of the software project that had infinite time and infinite budget, and it still failed. So all these software developers who keep saying, man, if we just didn't have these budget constraints or these time constraints, we could build wonderful stuff. Well, this team didn't have those constraints, and they still failed because they just kept building framework after framework after framework. There was nobody there holding their feet to the fire and saying, are you delivering value? So that's one of the things that we keep harping on within ThoughtWorks is there value in the thing that we're doing here? Value as measured by business, and maybe there is business value of stripping out old code for a new web framework because it does give you some new capabilities like feature toggles and the ability to do A/B testing or something like that. But we always try to focus on, is there real value in the thing that we're doing here? Not, is it just some sort of interesting puzzle that we're trying to solve?
So some of the quotes you've mentioned on your website, such as, those who cannot remember the past are condemned to repeat it, and the past is never dead, it's not even past, struck a chord with me. How do we help our young engineers understand the importance of learning our history?
Well, I'm trying next year. I'm doing this 90-minute talk. It's going to be 12 stories every architect should know, and I'm actually thinking about writing it down in book form because I think it's interesting stuff. It's important lessons to learn about things that you put together, and it seems a shame to have to reinvent the same and have to stumble across the same problems over and over again. And that's, eventually sciences, as they mature in engineering practices, they come up with ways not to reinvent the wheel over and over again. But we still have a real problem with that. There's a great quote, and I can't remember who to attribute this to. I believe his last name is Cook. But he said that we've been sold this idea that software components were like swapping out Legos, but the reality is it's much more like organ transplants. And so I think that's still true, that we haven't quite figured out how to do this software engineering stuff quite right yet.
So can you discuss clever code, maybe with an anecdote, and why you think it's hard to maintain?
I mean, clever code is useful sometimes if it's doing something of value. Again, going back to value, but cleverness for the sake of cleverness is not good. And you see this a lot, actually, I believe, when people are trying to embrace multi-paradigm languages. So good examples of those are languages like Ruby or something like Scala in the Java ecosystem. Because the problem when you run into languages like that is that you can do code procedurally, you can do it in an object-oriented way, you can do it in a functional way, or you can do it in some sort of hybrid way. And that sort of encourages people to go down this rabbit hole of, ooh, how clever can I make this code? Particularly language that is as bendable as Scala, because you've got operator overloading, you've got first-class macros like a Lisp, so you can literally rewrite pretty much any part of the language to do anything else you want, which is very clever, but then it's really hard for other people to understand. A great example of that, I think, is, at least the last time I looked at it, was the build tool that's common in Scala, the SBT, the simple build tool. I think it's parenthetically, I think it's worth mentioning that anytime a tool feels compelled to put the word simple in the name of the tool, it's probably not. It's probably marketing. Just like the Simple Object Access Protocol, SOAP, I wouldn't call that necessarily simple. But so anyway, one of the things that everybody knows about operator overloading is that it's fine if you're using it to implement something like a vector, where you can add two vectors together and you can overload the plus operator to marry two vectors together. But it's a bad idea to just invent new operators out of whole cloth, because you eventually end up recreating a language like APL. Well, if you look at SBT, they did exactly that. The bang equals greater than sign means do a make, and the bang less than, percent sign means this other thing, which means that if you live 35 plus hours a week in build files and you remember that language, it's beautiful and elegant and you can get a massive amount of stuff done with almost no effort. If you only have to visit that once a month, it is absolutely incomprehensible gibberish. And anyone who doesn't know all that context is going to be gibberish as well. So I think that's a danger that you get into in multi-paradigm languages. It actually takes, I think, extreme team discipline to make sure you stick with one paradigm and don't create overly clever stuff, because developers love clever stuff. I mean, that's part of, people get into software development because it's puzzle solving. And so developers love clever stuff. And it's one of my old quotes is, developers are drawn to complexity like moths to a flame, often with the same end result.
Sounds a bit like regular expressions. So eliminating complexity was discussed in the book that you were involved with, 97 Things Every Software Architect Should Know.
Yep.
How do we eliminate complexity, and do you have any other examples?
Well, it's really just focusing on what is the real value. That was I was lucky in that 97 Things Every Architect Should Know book, because I was one of the first people that he contacted. So I got a nice juicy one about essential versus accidental complexity in there. So that's one of the things, is understand what is essential complexity versus accidental complexity, which is we just figured out interesting ways to make it complex versus it's just a really complex problem to solve. So for example, genomic analysis is just a complex problem to solve. It has essential complexity, but you could make it a lot more complicated by adding your own accidental complexity on top of it. And a great example of this is of essential versus accidental complexity is one of the other stories from my 12 stories. It's one that Dave Thomas, who co-wrote the Pragmatic Programmer book. I don't think he's actually written the story anywhere, but I heard him tell this story, and I got permission to talk about it in my talk. A long time ago, Prag Dave, and he's always called Prag Dave, by the way, because there were two Dave Thomases that signed the Agile Manifesto, OTI Dave Thomas and Prag Dave Thomas. So they're always distinguished with that epithet to keep them apart. So Prag Dave Thomas, back before he was a publishing magnate, was a consultant, and he was brought into this company because they had a problem of routing internal mail communications, paper-based communications, because things kept getting misrouted. And so then it would take a day for it to get back to the message room and then get rerouted back to the original department. So it was driving them crazy. And so they had figured out a way to solve this problem with this really elaborate, and this is in the probably late 1980s, early 1990s, so they had come up with this optical character recognition system who would read the addresses and try to route it at the appropriate place, and they brought Dave in to help them write the software to make all this magic stuff happen. And so Dave sat in meetings with them for a couple of days, and then he said, when they reached kind of a lull, he said, guys, I'm sure you've probably already thought of this, and I feel kind of silly for bringing it up, but have you thought about ever just switching to colored envelopes? And they sat around in stunned silence and realized that, you know what? If different departments had different colored envelopes, it'd be super easy for humans to sort them, and they don't need this incredibly elaborate optical character recognition, automatic routing, all this stuff. And so they had contracted him to write all this software, and they ended up giving him a chunk of that money anyway, because he ended up saving them all the money they were going to waste building this thing, because it seemed like a clever puzzle to solve, because he got to the real essence of the problem. The essence of the problem is misidentification. Well, what mechanisms do you have to identify things? Well, there's color, and you're not using that, and that's a really easy thing to use to distinguish things. So that's a great example of the kind of simplicity that's obvious in hindsight, but it's really hard to come up with foresight. But you know it when you see it, but it's really hard to come up with it. And so as architects, I think we should strive as much as we can to try to find those kinds of things and harbingers for those kinds of, can we radically simplify this and still get the same result? I think that's our best battle against encroaching complexity.
Help us make SE Radio even better by completing our short listener survey at www.ieee.org/SE-Radio. Thanks.
So what pearls of wisdom do you have around successfully bringing changes into an organisation or the teams within the organisations?
We do this a lot, actually. I'm a consultant, so we get to see a lot of transformation kinds of things within organizations, and we've tried lots of different things over time, and I've gradually come up with a mantra I think is the best way to attack these things, which is that demonstration defeats discussion. Stop talking about how we're going to transform the engineering practices in DevOps or something like that, or start doing database migrations. You have to show them how that's going to work, and then you can have an objective conversation about it. Because if you, as a developer, you get really excited about something like DevOps, you go to operations and say, oh, I'm really excited about this, they're going to say, oh no, that's impossible here. Our system, our ecosystem is way too complicated to do that with. They'll find every reason in the world to say no. But if you can show them, even in a simple version of it, that, hey, this does actually work, then you can win them over a lot more easily. Because you have tremendous inertia anytime you're trying to get a transition to happen. Because what happens is, even if people are excited about doing this new thing in this new way, as soon as one foot-pound of pressure is applied in terms of schedule or anything like that, they instantly revert back to the old way that they've done stuff, because it's just too hard to maintain a new way of doing things while other stuff is going on. And so giving them room to actually breathe and get used to it and don't chicken out, and show them that it's actually going to be useful. That's one of the ways that you can convince people that are kind of skeptical, is actually demonstrate. And so I've got a great anecdote for that as well that comes from Mike Nygaard, who I mentioned earlier. He's really super well known in the DevOps space. He was for a while the de facto CTO of this big box retailer, and he was trying to convince them that they should do a lot more automation around operations and DevOps, and it was essentially falling on deaf ears because, that's too complicated here. Our problem is way more complicated than everyone else's. We actually make a joke within ThoughtWorks that every single company we go to at some point says, well, our problem is way more complicated than every other company's. And of course it never is. It's pretty much always the same. But let me finish the Nygaard story before I don't want to leave people hanging on that. So
okay.
This is part of that
Yep.
demonstration defeats discussion idea. And so he was having a hard time selling this idea, and so he found a pain point. This is a technique that's known as consulting judo, because judo as a martial art uses your opponent's weight against them. And so what he did was found a pervasive problem within this ecosystem, which is they never had enough QA environments. They were always fighting over QA environments, and then people would try to share them, and they'd get conflicts and overlaps. And so he got an initiative started to spin up programmatically QA environments. And that did two things. One, it solved a real problem that they had. But the main thing that it did was demonstrated that, hey, this is possible within this ecosystem. And that was enough for him to get leverage to get operations to start taking him seriously when he started talking about actually doing this much more broadly. So that's part of this idea of, if you can show them that it is possible, you have a much easier time getting some sort of transformation like that to take hold and actually spread.
Yeah, so you've also discussed how to build engineering and DevOps practices to support continuous change and delivery. What advice do you have for us around this?
I think it's just an awareness that operations is really part of building software. It's a giant feedback loop. Operations is not something that can be done at the very end, because if a service pack comes out for the operating system and makes some of your code break, operations doesn't fix that. Development fixes that. So that's the definition of a feedback loop. So the tighter you can make that feedback loop, the less money and time you waste. And here's what I mean by that. So let's say the developer introduces some sort of defect in a traditional kind of siloed organization. The developer introduces some sort of defect, and it makes it through all the regular testing and the QA testing and all that stuff, and makes it to production. And for some reason, it will not work in the production ecosystem because of some operational factor, conflicting with a service pack, operating system, or clustering latency or something like that. To fix that, you have to throw that faulty code away and start over from the beginning. So what that means is you've carried that flawed code through some very expensive processes. You spend a lot of time and money on that code only to throw it away and start over. And so part of this motivation for getting operations much more aligned with development is speed up that feedback loop. Because if the development team now has a deployment pipeline, when they check in code, it tries to deploy that code onto a realistic production-like system, you can find out very early on that, hey, this is not going to work because of reasons X, Y, and Z, and you spend a lot less time carrying that flawed code. So it's more, and it's about engineering efficiency, but it's also about cost savings and, carrying broken artifacts a lot less time and speeding up that feedback loop to find defects and things that are not working correctly together.
So refactoring, or keeping technical debt levels low, often goes unseen, and it's only the conscientious that care enough to take the initiative to do it. How do you, as an architect, look for these attributes of excellence in individual team members and then train others, such as product owners and managers, to understand and recognize these attributes in team members?
Well, I think one of the things that's important to do is don't put roadblocks in front of people to discourage them from doing stuff you want them to do. A great example of that is expecting your developers to refactor aggressively, but then also force them to use feature branching and version control. Because those two things are contrary to one another. Because if you're living on a feature branch somewhere and you find some flaw in the code that needs to be refactored, you're going to get punished hard for doing that, just in terms of the merge conflict you're going to generate, because you're living on a feature branch. And so what that does is discourage developers from doing it, because they have to go an extraordinary long way out of their way to do the right thing. Versus using something like feature toggles. Feature toggles, you're still doing trunk-based development, but changes are still isolated from one another inside those feature toggles, but you are getting continuous integration, so you find out right away when two developers have bumped into one another because of a merge conflict or something like that. That's a great example of something that, first of all, getting out of the way of the kind of things you want people to do and make it so that they can reasonably do that kind of stuff. The other thing I think is just have awareness on the project that this is something that needs to be done. So a lot of our tech leads keep a kind of a technical debt backlog that's independent of the product backlog, and then they use time, either reserve time in each iteration or use spare time to kind of attack that technical debt backlog. Technical debt's one of those just realities of software. And it's not that it's not even that you've done something wrong. The problem is the entire software development ecosystem is in constant motion. And sometimes it changes out from underneath you and makes decisions that used to be correct, incorrect all of a sudden. So that's a lot of times technical debt is just the inadvertent, normal flow of the software development ecosystem. So I think it's an important bit of hygiene for projects to always have some sort of background restructuring, refactoring exercise going on to clean up old assumptions or things that have legitimately changed in the last while, because you're never going to get software right. The beautiful thing about software is it's really soft. And so if you do it correctly, you can keep a code base alive and healthy for very long periods of time. Now, we have several code bases that within ThoughtWorks that are more than a decade old, and they're pretty clean because there's been diligent effort throughout the life of that code base to pay attention to that stuff.
Yeah, what I often find, though, is that within a team you've got your code monkeys, which are pumping out the features fast, but they're also are making a mess, and then you've got your other developers which actually take a little bit longer to do things, but actually do things right, and they are basically tidy up their technical debt as they go. Often product owners and managers see the code monkey as being the hero, and the actual professional developer that's writing a good solid code, but he's a little bit slower, as being, I guess, the sore point of the team. So how do you actually go about, I guess, making the managers and product owners realise that?
That just shows they're tracking the wrong thing. They're looking at typing speed as a productivity indicator, but it's not, because this is not a purely mechanical kind of work. This is a thought-based, creative kind of work. So sometimes being slower and more creative actually adds more value. So I think this is really about the way that managers perceive value. So I would go out of my way to highlight something that one of the slower coders has done to greatly improve the code base for everybody else. The other thing I would say do, of course, I think this is a great idea anyway, is pair them up. Pair the lightning guys with the slower guys and try to get some of each of those characteristics into both of them. That may just mean you create a thunderstorm, which would be bad, because not everybody can pair with everybody else. But, that would definitely be a way to try to slow down the fast ones and make them more deliberate, but, also try to speed up the more deliberate ones. Hopefully not in a detrimental way.
It's a really good idea. In terms of empowering developers, what are some of the most effective ways you've found to do this?
So one of the things that we've discovered about developers is that the things that most companies really focus on, things like salaries and perks and that kind of stuff, our metaphor for that is oxygen. If you don't have enough, you're in trouble. But once you hit a certain level, that becomes less important. Money and other sorts of perks and other sorts of job characteristics start rising in importance. And one of those is autonomy. Developers, being creative kinds of people, like autonomy and the ability to make decisions about things. And so giving people more control over their world actually helps them, I think, be appreciated more, because they have more responsibility and therefore they get more credit for what they do. And you see a lot of companies go toward more of a product-based rather than project-based team structure, where the product kind of encapsulates that idea of this group of people working together to create some sort of unified thing versus just one project right after another.
Yeah, I can see with the autonomy. I know for myself it's been great, but then it's kind of like you've got to watch the developers that are looking for the meta work as well, as you put it.
Yep, absolutely. That's always something. I think the architect and tech lead has to keep a close eye on that, because it happens all the time. I would almost contend that you could go to virtually any software project and find some over-engineered stuff. And not even maliciously over-engineered, just, we're building, you're future-proofing here, or, we thought we'd try this here, and, just very casually. But, it is in the nature of software developers to solve puzzles. So we look for puzzles to solve everywhere.
So what are some of the techniques in creating high-performing teams that also keep levels of technical debt at manageable levels?
If I knew that, I'd be rolling around in big fat stacks of cash like Scrooge McDuck. It's Martin Fowler actually famously wrote at one point about it. It's really hard to measure productivity. How do you even measure that with software developers? So, creating highly productive teams, step one is figure out a way to measure productivity. It's one of those things, it when you see it. You've seen high productive teams. It's like you can marvel at it. It's like, wow, look at how much they are able to do with that small group of people. But it's a really hard thing to measure in any quantitative way, because there are lots and lots of different variables, and it's a messy thing. I think there are still lots and lots and lots of things that we have to discover about the engineering discipline of writing software. And it's just such a young science that we just haven't figured out some really fundamental things yet.
It's a bit like Scrum. Scrum's great at allowing teams to move fast and that, but it doesn't do a lot for dealing with technical debt and that sort of thing. So you've actually got to add other steps and processes on top of it, right?
Well, Rich Hickey, the creator of Clojure, has a great video called Simple Made Easy. And he talks about the distinction between simple and easy, which is a really important distinction. And he makes fun of Scrum, because every software project is a marathon. But he said, so what Scrum did was just say, okay, we're going to take this marathon and turn it into like 100 meter sprints. And so every week we're going to fire the gun again and get you to sprint for 100 meters, but you can't sprint a marathon. At some point you've got to take a step back and think about restructuring and refactoring and looking at the larger picture of that stuff, and maybe do something that seems like, is not relentlessly moving forward, but sometimes moving forward is not always the absolute correct thing to do.
You've written on building a technology radar. Can you talk a bit about that, like what the bubble is and the dangers of living inside it, and how to avoid it, and how to build and maintain that technology radar?
Well, that's this thing that we produce at ThoughtWorks a couple of times a year. In fact, we just did a face-to-face meeting that produces another radar, which will eventually be the March 2017 version of the ThoughtWorks radar. I think it's a super valuable document for us internally because what we're really doing is, because we're all over the world now from a ThoughtWorks standpoint. We're in 18 or 19 different countries now around the world. And we have lots of different software projects going on all over the place. And so getting a kind of consensus of what's really working well across the world and what's not working well, that's a really rare kind of breadth thing to be able to find. And our advantage, of course, is we're a consulting company, so we have lots of different projects going on. Sometimes we pick the tech stack, but sometimes we're working within the tech stack of an existing company, which gives us a kind of a unique perspective. And so the radar is really us taking advantage of this unique perspective that we have both across the world and across a large number of projects to see, well, how well does this thing work, and how well does this not work for its intended usage. So I think this is a good tool to help people kind of get out of their own kind of private technology bubble, because you don't really get a chance to assess a lot of brand new technologies when you're working on a long-term project. And so getting to dip your toe into kind of what's interesting and new, I think is not a bad way to keep track of what's happening and interesting in the world.
In just about all technology projects, or should I say technical projects, I've been part of, the biggest problems are just about always never technology-based, but rather people-based. Why is this, and what tips do you have on fixing the people problems?
Well, so this goes back to the history lesson stuff we were talking about before. Gerald Weinberg figured this out in the 1970s in his book, Secrets of Consultant. I believe it was that book, where he said it's always a people problem. No matter what it looks like, it's always a people problem. And that's the fundamental problem in software, is it's always a people problem. We've known that for a long time. We still haven't figured out a way to get around that. I think it's one of those things where we take 2 steps forward and 1 step back. So, I mean, we keep figuring stuff out. So I think, back when I first joined ThoughtWorks 12 years ago, Agile was still a kind of a fraught conversation with a lot of organizations who, weren't sure that kind of hippie stuff was going to work. And, you had to do a lot of selling on that idea. But over the last few years, we figured out where it works well and places where it doesn't work as well. And so we have a pretty good set of engineering practices around those ideas now. And I think that's, that's the way that we continue to move forward is, 2 steps forward, 1 step back, learn some new stuff, and then learn the implications of that new stuff and keep rinsing and repeating.
You've talked about avoiding yesterday's best practice from becoming tomorrow's AntiPattern. So what is an AntiPattern, and how do we do this?
Well, that's the name of one of my keynotes, is why does yesterday's best practice become tomorrow's AntiPattern? And AntiPattern is, of course, taken from the pattern movement. But most people misinterpret AntiPattern just as a synonym for bad. But you don't need AntiPattern to mean bad, because we already have a word for bad. We have the word bad. What AntiPattern really means is something that initially looks like a good idea, but then turns out to have been a terrible idea after the fact. And we have a lot of those things in software. But part of the problem is one that I talked about earlier, is this constantly shifting ecosystem that we're dealing with in software. So this is something that we're talking about in the evolutionary architecture book, because how do you build an architecture that evolves and can actually accommodate all this change? So here's a kind of a thought experiment that we're pitching to people. So take a computer and install an operating system and maybe an application server and a bunch of libraries, other stuff on it, and then unplug it from the wall and stick it in a closet for a year. At the end of the year, take it out of the closet, plug it back into the wall, plug it back into the internet, and what's the first thing it's going to want to do? 57 updates available, because even though you didn't change a single byte on that computer, the entire world kept shifting and changing around it. And this is one of the fundamental problems we have in software, is even a perfect decision today may be invalidated by the software development ecosystem tomorrow, because the entire thing shifts in a way that we could never have anticipated. And so that's why we're actually spending a lot of time and effort in thinking about this idea of evolutionary architecture. Can you add evolvability as one of those first-class abilities in software architecture? And what would it look like to build an architecture that can withstand these kind of unexpected changes that seem to pop up all the time? We refer to this as the Donald Rumsfeld problem, which is probably less known outside the U.S. Our former Defense Secretary, Donald Rumsfeld, very famously at one point made the distinction between known unknowns and unknown unknowns. And the real terror in software architecture, the unknown unknowns. Because you know about known unknowns. Okay, I need to add geolocation to this project, and I don't know anything about that, but I know that it exists, and I know the resources for it. It's the unknown unknowns, like we have this weird concurrency bug, and we can't figure out how to solve it. Those are all the things that end up nabbing in software.
So what does failure look like as an architect, and how do you deal with it?
Well, I think failure comes in a couple of flavors. One is misassessing the problem to begin with and choosing the wrong architecture that doesn't support the kind of things that you want. This is also known as resume-driven development, or chasing the next shiny thing from an architecture standpoint. Now, chasing the next shiny thing from an architectural standpoint, that's a great way to learn new stuff, probably not a good way to build effective software. The other thing that happens that degrades architecture is that you choose an architectural pattern for a perfectly good reason, but then people start degrading it for their own reasons. So let me give you a classic example of this. So as the architect, you choose a traditional layered architecture that isolates persistence and business rules and presentation in individual layers from one another. But then the reporting team comes to you and says, okay, look, going through all those layers is just too slow. We need access from the presentation tier directly to the database. Now, as the architect, you could let that happen and say, okay, well, performance is why we had to do that. But now you've thrown away the entire reason you chose that layered architecture to begin with. Because the reason you chose a layered architecture, at least one of the reasons, is layers of isolation. So you can easily make changes to the persistence library, for example, without affecting anything else. But now you've gone and coupled the top layer to the bottom layer, which means that you can't make changes anywhere through those layers without breaking everything. So that's a good example of choosing the correct architectural pattern, but then not policing it as people use it and end up letting it degrade over time because of negligence.
If you could go back in time and change the way you progressed through your career, what would you change?
I have no earthly idea, because I didn't have any sort of firm, concrete plan to begin with. And so trying to go back and reverse engineer that and fix it would probably just lead me to a terrible place. I was very explicitly told when I was in university that the only real career path in computers was to learn mainframe assembly language. And I decided to not take that advice, which turned out to be a really good thing. So I've been really fortunate in that I've worked on lots and lots of different software projects. I've been a consultant for a really long time, and so I've seen a lot of software projects and a lot of different kinds of things. And so I try to leverage my knowledge of history and how things fit together, kind of put a filter on the new world. For example, I'll give you a great example of that. In the microservices ecosystem, they are very slowly re-implementing all of the Corba named services. So, Corba was this ancient kind of integration technology back in the 80s and 90s, and they did a lot of distributed computing stuff, so much so that they created a bunch of different categories for Corba services. I think there were 8 of them. Naming, transaction support, service discovery, resiliency, and we're slowly re-implementing each of those things in the microservice ecosystem. So I could tell you what the near-term future of microservices is going to be. We're going to finish implementing the rest of those Corba services because they needed those facilities for distributed computing then, and we need a different flavor of those services for distributed computing now. So that's one of the advantages of having some sort of breadth and history, because these patterns do keep repeating themselves, and we keep solving the same problem over and over in slightly different, nuanced ways. So that's one of the best things about my career is the fact that I've been a consultant and have been able to look at a lot of different projects. The other thing is, so you mentioned one of my titles is the self-proclaimed title from ThoughtWorks, Meme Wrangler, which comes from the Dawkins definition of a meme as a viral unit of thought. And wrangle, of course, is to kind of herd or settle disputes for arguments. Once I kind of chose that title tongue-in-cheek from a ThoughtWorks standpoint, it became sort of self-fulfilling prophecy because now I'm actively looking for memes of things across the software development ecosystem. So meta work is more interesting than work is one of my memes. So is architecture is abstract until it's operationalized. So I'm now sort of a self-fulfilling prophecy now trying to find those kind of meta patterns within the software development ecosystem and talk about them in things like talks and keynotes.
So what advice do you have for software engineers thinking about making the transition toward architect-based roles, and what do they need to be aware of before moving in that direction?
The first thing I would do is take a serious look at your soft skills, particularly things like writing and speaking and that kind of stuff, because that's the thing that's going to blindside you as you move into the architect role. I would see if you can pair with an existing architect before you make a big leap, just to see if you like that job. Because a lot of developers get to become architects and they hate it. Because it's all meetings and it's all settling disputes and everybody has important stuff they care about, and they don't care about the other people's important stuff. And so a lot of technical people find that they don't like that leadership aspect of architecture. So if you can find a way to sample it, to try it before you buy it, I think that would be great. If you could pair with an existing architect for a day or two just to kind of get a feel for the job, I think that's a good idea. And, start looking at things like architectural patterns books and some of the technical stuff around architecture and see if you really like that. I find that one of the things that appeals to me about architecture is the kind of, piecing together systems that really react the way that you want them to in terms of all these architectural characteristics you've identified. I think that's a really interesting challenge, and it doesn't have to turn into meta work. So if somebody really likes that kind of intellectual challenge, then it's a perfect fit. But it's hard to know if you like that until you've actually tried it.
Yeah. I know for myself that it's really hard to basically move from engineering to architecture and back and forth. And I mean, I'll spend some time in an architectural role and then get really frustrated because either I'm losing my technical skills or it just feels like I'm just too far removed from everything, and then vice versa as well. When I'm actually spending time I'm in deeply technical stuff, I feel that I need to get up, I need to step right back and see what's going on across the broader picture. Do you find that as well?
Well, I think that's a challenge that every architect has to solve for their own organization. Is how much technical stuff can they carve out? How much technical stuff should they carve out? The problem that a lot of brand new architects have is they try to micromanage every single decision on projects. You should give that up. You should let tech leads make decisions. So you pick the architectural style, let them pick the details of how to implement that architectural style, because what you're doing is allowing them enough context to gradually grow into be an architect as well. So that's another pitfall, is micromanaging all these decisions, because now you have the power to tell people which framework to use. I'm going to tell them now. Sometimes you're better off letting them choose for themselves.
Yeah. What have we not discussed that we really should have?
We've talked about a lot of stuff. So one of the things I think is really critical to becoming a really successful architect is learning how to present your ideas really well. Using tools like Keynote or PowerPoint or the slide stuff in Google, that turns out to be a really critical skill, because you've got to sell these ideas to management. You've got to provide detailed technical things to sell these ideas to developers. So if there's one kind of soft skill that you've never had any instruction in, it's probably doing presentations, both from putting slides together in an effective way to just the mechanics of actually presenting in front of a group of people. The more practice you can get for that, the better off you are, because it's definitely something that gets better with practice.
So whereabouts can people find out more about what you do, Neal?
So I'm on Twitter. My Twitter handle is NEAL, the number 4D, which is pronounced Neal Ford. So it's the LeetSpeak version of my name. My website is nealford.com, but it's Neal with an A, not an I, so it's NEALFORD.com. And the Evolutionary Architecture website is where you can find out stuff about the book that's coming up. I work for ThoughtWorks, so that's thoughtworks.com, which is a very interesting place that is always hiring passionate developers. And I'm also co-chairing the 2 O'Reilly Software Architecture conferences, one in New York coming up in April, and the other one in London this year coming up in October. We had great events in New York in October last year, and expect to have great events again this year, including something that I think is absolutely unique in the conference space, which is we have a party game called Architectural Katas, which a lot of people do now. Take these little problems and build architectures for them. We're doing it as a conference-wide party game with drinks and pizza and judges and prizes and all that sort of stuff. So we have figured out a way to get architects to network and do work under the guise of having fun at a conference. And the last time we did this, we were having a hard time getting them to go get drinks because they were so caught up in the little architectures they were designing. So it turned out to be a great fun thing. So we're going to do that again in New York and London, because it's a great way to network, but it's also a great way to play around with designing architectures with drinks. What could be wrong with that?
Yeah, sounds good. So Neal, thanks for joining us today.
It's been my pleasure.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.